So this video is for 7.3. Make sure there's a typo. It says 7.2, but it should say 7.3, the law of cosines. And you can go ahead and read through the first page of notes. It walks you through the derivation of the law of cosines and where the formula comes from. On the next page of your notes is the actual law of cosines. It's really all the same version. So make sure you memorize it. All that's happening in the three different versions is that they're changing what side you're looking for, but the names are really ambiguous. So the way that I put it in my head is that I start the formula with a squared, which means I have to end the formula with a. So it starts and ends with a, and then everything in between is the other two letters. So b squared plus c squared equals minus 2bc cosine A. Now this formula does come in another form where they solve for the angle. And so let me go ahead and do that. To be very honest, I don't have that version memorized. I just go ahead and I do it when I need to. So if I were trying to solve for angle A, it'd be a squared minus b squared minus c squared divided by negative 2bc, and that would equal cosine A. And you'd have to arc cosine both sides. Lots of times you will see this version. This negative is distributed up top. So it says b squared plus c squared minus a squared. All that happened is everything in top changed its sign, and they made it so it wasn't a negative a, it was a minus a, but it's all the same thing. All over 2bc equals cosine A. Again, I don't have this version memorized. This right here in this box is the one version I have memorized. And then from there I can derive whatever it is that I need to do. And then this right here is the angle version I was talking about. So let's go ahead and use the law of cosines. So it says that a surveyor wishes to find the distance between two inaccessible points A and B on opposite sides of the lake. While standing at point C, she finds that B's length is 259 meters and A's length is 243 meters. The angle, okay, so let's talk about this. This right here, when it says angle ACB, the letter in the middle is the angle they were talking about. So this angle C right here is 320 degrees and 40 minutes. Find distance C. So first things first, if I were doing this, I'm going to write down c squared equals a squared plus b squared minus 2ab cosine big C. I'm also going to go ahead and I'm going to convert this angle C, 320 plus the 40 over 60, which makes 332.6 repeating. So now that I have angle C, I can plug the stuff in that I want. So c squared is going to equal a squared, which is 423 squared, plus 259 squared, minus 2 times 423 times 259 cosine of 132.6 repeating. Now, using the calculator that you have, honestly, I would do these two first, and then I would do all of this, and then subtract the two. Make sure that if I were you, I would stow that number in so you're not rounding and causing any error when you type it in your calculator. And then don't forget you have to square root. You have c squared equals, so let's do the c squared first. C squared equals approximately 394,510.6. Don't chop it off. Keep that whole decimal. It's just an approximation. But then when you square root it to find C, it is 628 meters. Let's go ahead and try another one. So this one says solve triangle ABC if angle A is 42.3 degrees, B is 12.9, and C is 15.4. So just going to draw a triangle. If I call this right here angle A, that means this side over here is little a. And then we'll call this one B, 12.9. And if that's B, then this is B. Then this is C, and down here is little c, which is 15.4. So let's set up the law of cosines. I don't have any complete ratios in this case, so it's definitely a law of cosines. So if you have a complete ratio, an A and an A, a B and a B, a C and a C, then do law of sines. But if you don't have a complete ratio, then do law of cosines. Just be a little bit careful if you choose to go law of sines that you don't have an ambiguous case. So the first thing I'm going to do in this problem is I'm going to find little a. So a squared is going to equal b squared plus c squared minus 2bc cosine a. I know that it seems a little bit redundant that I write the formula down over and over again, but when you write the formula down, it is easy to find out if you even had the formula wrong to begin with and find you more partial credit. A squared equals 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 cosine of big A, which is 42.3 degrees. Make sure you're in degrees, and then you can type it all in the calculator or do it piece by piece. But you should come out with a squared, not the square root yet, just a squared equals about 109.7. So when you square root that, a is going to equal about 10.47. So now I know a over here is 10.47. And I just want to highlight something. If I go in here at this point, now I do a full ratio, a and a. But if I go in here at this point and choose to do law of sines, it matters who I find first. I need to find B first, not C. And the reason that is watch. Side, side, angle. I don't want to find side C or angle C first because angle C could be the answer that comes out or the supplement version. So I want to find angle B first so that it forces C to be the right thing. So I'm going to find big B first so that I force C to be the right version. So I'm going to do law of sines, and in this case, I can't avoid using my rounded answer. So hopefully you have little a still on your calculator screen. Go ahead and stow that. I'm going to use my rounded version, so our answers might be slightly different. But in good habits, you should store that and not use the rounded version. So I'm going to do sine of 42.3, which was big A, degrees, over 10.47, side A. You can have it flipped over. It's fine either way. Equals sine B over 12.9. I'm going to cross multiply and divide, and then you're going to get a decimal, and you're going to have to arc sign it. And when you're done arc signing it, you should get that big B equals 56 degrees. Please pause the video at this point and go ahead and make sure that's what you get. And now we know what big B is. We can find big C by doing 180 minus the 42.3 minus 56. So big C is equal to the 81.7 degrees. This note right here is warning you about the law of sines in the ambiguous case that I was talking about earlier. So go ahead and take a second to read that. So I'm going to go ahead and let you do the next one, but I'm going to give you the answers. I am going to warn you of one thing, though. A side, a side, and a side, which means when you do the law of cosines to start, you are going to have to arc cosine at the end so you can get that angle. So when you do this, though, you should get that big C is equal to 109.9 degrees. Big B is equal to 45.1 degrees. And big A is equal to 25 degrees. So go ahead and do that problem and verify that's what you get. the next problem, it says find just angle B to the nearest whole degree. So if I'm going to find angle B, I start with B. So B squared equals A squared plus C squared minus 2AC cosine of big B. So let's plug stuff in. B is across. This is B. This is A. This is C. So I'm going to get 6 squared equals 11 squared plus 9 squared minus 2 times 11 times 9 cosine of big B. This is what I was talking about earlier. I don't have the other version memorized. I'm just going to go ahead and solve. So I'm going to have 6 squared minus 11 squared minus 9 squared divided by negative 2 times 11 times 9. So if I were you typing this, I'd type the top, and then I'd type the bottom, and then I would divide the two, equals cosine of B. So you type this in your calculator, and you arc cosine it, and you should come out with B equaling to the nearest degree, 33 degrees. This table down below walks you through all the different cases of when to do what. So if you're a little bit lost in when to do law of sines, law of cosines, how to find the missing piece, this might help you. My rules are, if you have a complete ratio, you want to do law of sines. Just be careful. Because of the ambiguous case. If you don't have a complete ratio, so in all other cases, you're going to do law of cosines. And then, if you have two angles, don't forget you can do 180 minus, we'll call them A and B, to find angle C, that third angle. This is what's summarized throughout the table. Okay, last little piece of this section is called Heron's area formula. When we found area with law of sines, we did 1/2 side sine the angle. In this case, we can't do that because I don't know the angle. So you can go ahead and find the angle and do the other version if you want, or you can use what's called Heron's area formula. So to do Heron's area formula, first of all, you have to find the semi-perimeter, which is S. And then once you do that, you're going to do this formula right here. So first of all, really the semi-perimeter, add up the sides, A plus B plus C, divide them by 2. And then you're going to use this and plug it in down here. So let's look at this example. So the distance as the crow flies, that means like in the air as the crow flies, no stop signs, traffic, from Los Angeles to New York is 2,451 miles. So here's LA, far, far away. New York is 2,451 miles. New York to Montreal, okay, hang on, time out. Not accurate. LA is down here. New York's up here. 2,451, a little bit better. From New York to Montreal. Montreal's way over here in Canada. $331. From Montreal to Los Angeles, the last piece of the triangle is 2,427. What's the area of the triangular region? So, step 1 is to find the semi-perimeter. So you're going to do 331 plus 2,427 plus 2,451, all divided by 2. When you do this, store it in your calculator. You should get 2,006 2,604.5. Once that's stored in your calculator, we can do our formula. So the area is going to equal square root. So at the end, don't forget to square root. S times S minus A, S minus B, S minus C. So you can type in the 2,604.5 every time, or you can use the Stowe recall value. But when we plug this in, we get area equals, I'm going to call it S. So S minus A, whichever one you want to call A, it doesn't matter. Because they're all going to get multiplied together, and multiplication, the order does not matter. And then when you're all done with this, you need to square root the answer. So you should get to the nearest whole meter that the area is 401,700 labels miles squared. And that is 7.3.